lesson, we're going to introduce the index laws. So let's have a look at what an index is, first of all. So when a number or pronumeral is repeatedly multiplied by itself, it can be written in a shorter form called the index form. So here we've got a to the power of x. A is the base, so that's the pronumeral or the number that is going to be multiplied by itself. The x, okay, the small value written on top of the base is your index. So that index is going to tell you how many times you're going to multiply your base by. Okay, so index, it's also called a power or exponent. So there are three words that mean the same thing. So for example, here if we have 2 to the power of 3, that does not mean it's 2 times 3, but it's 2 times 2 times 2. And 2 times 2 times 2 is evaluated to 8. So this is written in index form, this is written in expanded form, and here we've got the value as a basic numeral. Also note that when you've got a pronumeral or a number without an index, it actually has an index value of 1. Okay, so the in a to the power of 1 is the same as a. Now let's have a look at some examples. So we've got right in expanded form. So in part A, we've got x, y, all in brackets to the power of 2. That means that both x and y need to be multiplied by themselves. So we can either write y times xy, or we can even write it as x times x times y times y. Here we've got 2a to the power of 3, b to the power of 2. That means we've got 2 times a multiplied for 3 times and b multiplied for 2 times. In example 2, we've got write in expanded form and then evaluate. Okay, so we've got negative 3 all to the power of 2. So that means that we've got negative 3 multiplied by itself. Okay, and negative 3 times negative 3 evaluates to 9, because negative times negative is positive and 3 times 3 is 9. We've got an important note here. When you've got negative 3 to the power of 2 without the brackets, then it's only the 3 that is power of 2. Okay, so the negative stays there, and then we just go 3 times 3, because only the 3 has the power of 2, not the negative, and that would give us a value of negative 9. Okay, so make sure you see the difference between these two. Then we've got 2/3 to the power of 3. So indices work for fractions as well as decimals, okay? So we've got 2/3 multiplied by itself 3 times 2/3. And when you evaluate it, that gives us 2 times 2 times 2 is 8, 3 times 3 times 3 is 27. Example 3 asks us to write in index form. So they are actually in expanded form, and we just need to put them in index form. So I've got 4 and 4 here. So I'm going to put 4 to the power of 2 here. I've got a, and a. So we've got a to the power of 3. And then 1b. So I'm just going to put b, and we avoid all the multiplication signs. In part B here, we've got negative 2 times negative 2, so it's best if we put them in brackets, okay, negative 2 squared, and then we've got g and g, so we've got g squared as well, and then we've got h, and h, which gives us h to the power of 3. Okay, so that's some basic work with indices. Now let's have a look at the index laws. So law 1 tells us that when terms with the same base are multiplied, all we need to do is add the indices. So if we've got a to the power of m times a to the power of n, all we need to do is leave the same base a and then just add the powers. So for example, if we've got 4 to the power of 2 times 4 to the power of 3, because it's the same base, which is 4, that means it's 4 times 4 times 4 times 4 times 4. In total, it is 4 to the power of 5. So all we needed to do was add the powers. Law 2. Law 2 states that when terms with the same base are divided, then the indices need to be subtracted. So for example here, we've got a to the power of m divided by a to the power of n, okay, which we can write as a fraction as well. All we need to do is to subtract the powers. I'll give you an example here. If we've got 5 to the power of 4 divided by 5 to the power of 2, we can also write it as 5 times 5 times 5 times 5 over 5 times 5. So if we cross out one from the top, one from the bottom, one from the top, one from the bottom, we end up with 5 to the power of 2. So instead of doing all this work, we can apply the second index law, where we just subtract the powers. So that is in fact law 2. Let's have a look at law 3. So law 3, we've got when a power a to the power of m is raised to another power, then the indices are multiplied. So here we've got a to the power of m in brackets and then another power on the outside. All we do is multiply the powers. So for example, 2 to the power of 4 to the power of 3, okay, isn't that 2 to the power of 4 times 2 to the power of 4 and again times 2 to the power of 4? And then using the first index law, we add the powers. So 4 plus 4, 8, 8 plus 4 is 12. So we end up with 2 to the power of 12. So we can just apply the third index law and just multiply the powers, and we get the answer there straight away. Some more index laws here. So index law 4, when the base is a product, such as this, a times b, and it is raised, so every part is raised to another, to an index outside the bracket. Okay, so what we do is we go a to the power of m times b to the power of m, because a times b are both inside the brackets. Okay, so I'll just give you an example here. If we've got in the brackets 2 times 3 to the power of 2, then that means, isn't it 2 times 3 times 2 times 3? So we can just write it as 2 to the power of 2 times 3 to the power of 2. And all we need to do is to assign that index to both values inside the brackets. Let's move on to index law 5. So pretty much the same index law as 4. However, now we've got a fraction. So when the base is a fraction, multiply the indices of both the numerator and denominator by the index outside the brackets. So as you can see here, I've got a over b to the power of m. That means the same as a to the power of m, b to the power of m. So I'll just give you this example here. Let's say we've got 4/5, and 4/5 is to the power of 2. That means that we've got 4 over 5, again times 4 over 5. So doesn't that result in 4 to the power of 2 over 5 to the power of 2? So we can avoid this middle part here, this middle step here, and we just go 4 to the power of 2 and 5 to the power of 2. Always remember that the power goes for the numerator and the denominator. Then we've got another rule that applies for indices where we've got a power of 0. So any term excluding 0 with an index of 0 is equal to 1. Okay, so any pronumeral or any number to the power of 0 is equal to 1. Where does this come from? So this comes from this following proof. So let's say we've got 7 to the power of 2 divided by 7 to the power of 2 using the second index law. Isn't that 7 to the power of 2 minus 2, which is equal to 7 to the power of 0? And if we work it out another way, where 7 to the power of 2 is divided, like this, over 7 to the power of 2, and then we expand to 7 times 7 over 7 times 7. If we cross out 7s from top and bottom, don't we end up with 1? So therefore, that means that 7 to the power of 0 ends up being 1. Okay, so that is a proof that anything to the power of 0 is equal to 1. Now let's have a look at some examples. We've got simplify the following. So all we need to do here is start with the numbers first. So 2 times 3 is 6. We've got a to the power of 2 times a. Now here a has a power of 1. And all we do is we add the powers because we are multiplying the same base. Okay, so now we've got a to the power of 3. And then here we've got b to the power of 3 times b to the power of 4, and that gives us b to the power of 3 plus 4, 7. And that is ready. Part B, we've got division. I would suggest that with division, you write them as a fraction. So we've got 2x to the power of 5, y to the power of 4, over 10, x to the power of 2, y to the power of 3. So let's just simplify the fraction first. 2 into 2 goes 1, 2 into 10 goes 5. Okay, so definitely we've got 5 at the bottom. And then we've got x to the power of 5 divided by x to the power of 2. 5 minus 2 is 3, and that is applying index law 2. Then we've got y to the power of 4 divided by y to the power of 3. 4 minus 3 is 1. Okay, so you can write the 1, or we can leave it just as y. Okay, we don't need to write the power of 1. Over here we've got 2n to the power of 4 to the power of 3. So everything within the brackets needs to be associated with this power of 3. So we've got 2 to the power of 3. Don't forget there's times between the 2 and the n to the power of 4. And then we've got n to the power of 4 to the power of 3, which is 4 times 3, 12. And so we just simplify that to 8, because 2 times 2 is 8. 8n to the power of 12. Part D here, we've got 3a over 5b cubed all to the power of 4. So let's start getting rid of the brackets, okay, expanding the brackets. So we've got 3 to the power of 4. And then we've also got a to the power of 4. And then we've got 5 to the power of 4. And we've also got b to the power of 3 times 4, 12. Okay, so a step at a time, and we've removed the brackets. So 3 to the power of 4 is 81 when we work it out. The a to the power of 4 stays there. We've got 5 to the power of 4, which is 625. And then we've got b to the power of 12. And then part E here, so let's do step by step. Let's get rid of the brackets first. So here we've got the 2. The 2 is not inside the bracket, so it's not impacted by this power of 3. But this x is. So we've got x to the power of 6, and we've got y to the power of 1 times 3, 3. Times, we've got the 5. I'm just going to copy the rest for now. That's at 3, y to the power of 4, over 10, x to the power of 4, y. So now what I'm going to do is I'm going to simplify the numerator, okay? 2 times 5 is 10. And then we've got the x, we've got 6 plus 3 is 9. And with the y, we've got 3 plus 4 is 7. Over, we've got the 10 as well at the bottom. And we've got x to the power of 4 and y. And so now what we do is we need to simplify the fraction as much as possible. So we divide top and bottom by 10. So that gives us 1 and 1. And then we've got x to the power of 9 divided by x to the power of 4, which is x to the power of 5. And y to the power of 7 divided by y to the power of 1 is y to the power of 6. And now we'll just have a look at this last slide here, which says evaluate the following. Okay, so these examples are require a numerical value. So remember that anything to the power of 0 is 1. So here we've got 2b to the power of 3 to the power of 0. So pretty much the answer is 1. Over here in part B, we've got negative 4 on the outside of the brackets. So we just need to leave the negative 4 as is. Don't forget that there's times between the negative 4 and the brackets. So it's negative 4 times. All of this resolves into 1. So negative 4 times 1 is negative 4. And then with the last example here, we've got 5x to the power of 0 minus all of this in brackets to the power of 0. So remember, the 5 is not impacted by the power of 0, but the x is. So x to the power of 0 is 1. And don't forget that there is a times between 5 and x to the power of 0. So we've got 5 times 1 minus all of this is going to end up being 1. Okay? So 5 times 1 is 5. 5 minus 1 is equal to 4. And that's your answer.